Assalamu alaikum. Today we are going to do 9709 paper 332 May June 2024. Question number 1, it says that you have to sketch the graph for y is equals to mod of x minus 2a where a is a positive constant. So let me make the x-axis and y-axis. So this is the y-axis and this is the x-axis, and if you look over here, this is going to be 2a. One point is going to lie, especially the vertex, this is going to lie over here, and the y-intercept is also going to lie here, and the graph is going to look like this. Okay, it is going to be a modulus type graph with these 2a and 2a on the as a vertex. Part B says that solve the inequality. Okay, so to solve the inequality, I'll use the positive and negative method. One time I'll take it positive and the other time I'll take the mod part as negative. So it will be 2x minus 3a less than x minus 2a, and the other time it will be 2x minus 3a less than minus x minus 2a. So if I simplify the left hand side, it will be 2x minus x less than minus 2a plus 3a. The value of x will be less than a. This is one solution to the inequality. Similarly, 2x minus 3a less than minus x plus 2a. So it will be 3x less than 5a, and the solution to the inequality will be 5 divided by 3a. So let's move to the next question. Question number 2. Question number 2 is to do the partial fractions. Since the numerator power and the denominator power, they both are equal, so we are going to, this is an improper fraction na? So we'll convert it into we'll do long division of it. So let's do the long division. I'll keep the numerator inside, which is 6x square minus 9x minus 16, and 2x square minus 5x minus 12 outside. After that I'll multiply it with 3, so it will give me 6x square minus 15x minus 36. I'll change the signs, and the 6x square and 6x square will cancel out. Minus 9x plus 15x will give me 6x, and this will give me 20. Now I'll convert this function f of x. I'll write it as quotient of x plus remainder divided by d of x. So the quotient is 3. The quotient is 3, remainder is 6x plus 20a divided by 2x square minus 5x minus 20. Now I have to apply the partial fraction on this part, but before doing the partial fraction, I'll make the factorization of the denominator. The denominator is 2x square minus 5x minus 20, sorry, it's minus 12. it's minus 12. So let's do the factorization for this. It is 24 and 5. It is going to be 8 and 3. So 2x square minus 8x plus 3x minus 12. 2x is common, plus 3 x minus 4. One bracket will be x minus 4, the other bracket will be 2x plus 3. Now let's do the let me write it. 6x plus 20 divided by x minus 4 into 2x plus 3. Now we have to do the partial fraction of this. So partial fraction of the fraction. So the partial fraction will be 6x plus 20 divided by the two brackets x minus 4, 2x plus 3. Since it's a linear, so a will be a over x minus 4 plus b over 2x plus 3. So if I simplify, it will be 6x plus 20 equals a bracket 2x plus 3 plus b bracket x minus 4. Now I'll simplify by taking, I'll let the value of x to be 4 so that I can get rid of b. So 6 times 4 is 24 plus 20. It will be equal to a into 4 2s are 8, 8 plus 3, 8 plus 3. So 44 will be equals to 11 times a. So the value of a will be 4. Now similarly, I let the value of x to be minus 3 by 2. Now I'll substitute minus 3 by 2, and 6 times minus 3 is minus 18 divided by 2 is minus 9 plus 20 equal a will become 0, and similarly for b it will be b bracket minus 3 by 2 minus 4. So minus 3 by 2 minus 4 will be 11 by 2. So it will be 11 equals minus 11 by 2b. So the value of b will be minus 2. The final answer for this is going to be 3 plus a is 4 divided by x minus 4 and plus b. The value of b is minus 2. So 2 minus 2 divided by 2x plus 3. Let's move to the next question. This is the final answer. The partial fraction of the fraction given. Now question number 3. Question number 3 says that the variable x and y satisfy the equation this, where a and b are constants. Show that graph of y against x is a straight line. So basically we need to convert this equation into a linear equation so that we can show that it is a straight line. So what we can do is, in the first step we will take log on both sides. So we will have ln a 2y minus 1 ln b x minus y. The power will come before the log into ln of a equal x minus y into ln of b. Now we'll do the expansion. So it will be 2y ln a minus ln a equals x ln b minus y ln b. Now we'll collect the y terms on the left side and the other terms on the right side, because we need to make it look like y equals to mx plus c. So it will be 2y ln a plus y ln b equal x ln b plus ln a. Now we can take y as common. We'll have 2 ln a plus ln b equal x ln b plus ln a. Now y will leave y on this side. This is going to go to the other side. It will divide with both. So it will divide as 2 ln a plus ln b plus ln a divided by 2 ln a plus ln b. Now if you could compare it with this, so linear equation is y is equals to xm plus c. So basically this portion is the gradient and this portion is the y-intercept. Okay, so let's move ahead. Given that a is equals to b cube, state the equation of straight line in the form of y equals to px plus q, where p and q are rational numbers in their simplest form. So we already have a linear equation. This is the linear equation that we have made, straight line equation. So but we know that a is so a is equal to, we know that a is equal to b cube. So we'll just substitute wherever there is a, we'll substitute it with b cube. So it will become y equal ln of b divided by 2 ln b cube plus ln b plus ln b cube divided by 2 ln b cube plus ln b. Now the two that are before ln will take it to the power. It will become y equals ln of b divided by ln b power 6 plus ln b plus ln b power 3 divided by ln b power 6 plus ln b. Now they are adding, so the two logs, they will multiply. So b power 6 multiplied by b will be b power 7. So it will be y equals to ln b divided by ln b power 7 plus ln b power 3 divided by ln b power 7. Now the power, that is the power, we can bring it before the ln. So it is going to look like, so yeah, it is going to look like y is equals to ln b over 7 ln b plus 3 ln b divided by 7 ln b. Now ln b and ln b will cancel out like this. So there was, okay, I have skipped the x since the start, so let me put it back now to write the final answer. Y is equals to 1 divided by 7x plus 3 divided by 7, like this. Let's move to the next question. The next question number 4 says that the equation of a curve y is this. Find the gradient of the curve at the point where y is equals to 1. So basically we need to find out the dy by dx over here. So for that we have to apply the product rule. Let me write down the product rule over here. uv is equals to uv dash plus vu dash. Now I'll apply the product rule on this one separately, and I'll apply the product rule on this one separately. Let me mark this as 1 and this as 2 so that there is no confusion later. So for the first one, if I apply, which is y e raised to the power of 2x, if apply the product rule, u will come as it is y. The differentiation of the second, which is e raised to the power of 2x as it is, multiply with the differentiation of the power, plus the second as it is, which is e raised to the power of 2x, into the differentiation of y, which is 1 into dy over dx. So if I simplify, it will be 2y e raised to the power of 2x and e raised to the power of 2x dy over dx. Now after that, it is the second one, which is y square e raised to the power of x, which will be I'll apply the product rule again. It will be the first one as it is, the differentiation of the second, e raised to the power x as it is, into 1 plus e raised to the power plus the second as it is, e raised to the power of x, into the differentiation of y square is 2y into dy over dx. Now if I simplify it further, it will be y square e raised to the power of x plus 2y e raised to the power of x dy over dx. This is the differentiation of both of them. Now I will write both of them together. Now let me just copy it down. I'll write down both of them together as one simple differentiation. The first, and followed by the second, and plus, and there will be a equal sign, and it will be a 0 because the differentiation of 6 is 0. Now after that, we know that the value of y is 1, but we don't know the value of x. So to find out dy by dx, we also need to have the value of x. So we will substitute the value of y in the above equation, the actual equation that is given in the start, and we will find the value of x. Now it is y e raised to the power of 2x. Let me write down for x. Now the equation is y e raised to the power of 2x plus y square e raised to the power of x equals to 6. Now I'll substitute the value of y as 1. Now if you put y as 1, it will become e raised to the power of 2x plus e raised to the power of x is equals to 6. Now if you rearrange it, it is going to become e raised to the power of 2x plus e raised to the power of x minus 6 equals to 0. Now what we can do is, we can let e raised to the power of x as a. It can be any alphabet. So it will be a square plus a minus 6 equals to 0. So the two factors will be 3 and 2. So a plus 3 and So a plus 3 and a minus 2. So I'll put a plus 3 equals to 0 and I'll put a minus 2 equals to 0. This will give me the value of a as minus 3, which is not possible. Why not possible? Because I know that a is basically e raised to the power of x. So this is not possible for us to solve. What about this one? It is e raised to a is equals to 2. So e raised to the power x will be equal to 2. So I know that e raised to the power of x is 2 basically. So if you look, I will not find the value of x in particular. Why not? Because if you look at the question, I need to put the value of e raised to the power of, in terms of e raised to the power of x. If e raised to the power of x is 2, so what will be the value of e raised to the power of 2x? It will be 4, taking square on both sides. Now I have these two values. I just need to plug it in over here in this formula, the one that we just found the derivative. So let me put it here. I'm running out of space, so I'll have to add another page. Yeah, so it will be, let's substitute the values of e raised to the power of x and e raised to the power of 2x. So it will be 2 times y is 1, and then it is e raised to the power of 2x, which is 4, plus e raised to the power of 2x is 4 into dy over dx plus 1 square. E raised to the power of x is 2 plus 2 times y is 1, it is 2, and dy over dx and equal to 0. Basically I need to find out the gradient, which is dy by dx, so I just need to simplify it further. It will be 8 plus 4 dy over dx plus 2 plus 4 dy over dx. I'll keep the dy by dx term on this side. I'll take all the rest on the other. So it will be 4 plus 4 dy by dx plus 4 dy by dx will give me 8 dy by dx, and it will be equal to minus 10. So dy by dx will be equal to minus 10 divided by 8. So if I simplify, it will be 5 minus 5 by 4. So the gradient will be minus 5 divided by 4. Let's move to the next question. Question number 5 says that it is given that the equation e raised to the power of 2x equals to this has only one root. Show by calculation that this root lies in the interval of 0.7 to 0.8. So first of all, I just have to substitute. I have to bring everything to one side so that I can make it like an equation. So e raised to the power of 2x minus cos 3x minus 5 is equal to 0. After that, I will substitute one time the value of x as 0.7 and the other time I'll substitute the value of x as 0.8. So e raised to the power of 2 times 0.7 minus cos of 3 into 0.7 minus 5. Similarly, I'll substitute the value of x as 0.8. I have to find the answers for both of them, which will give me e raised to the So it will give me the value of the first one as negative 0.4399, and for the other one it will give me the value of value as 0.6904. Now since the signs are changing, one sign is positive, one answer is positive and the other is negative, between 0.7 and 0.8, it means that there is only one root that lies between this interval. So let me write it as a statement. Sign change between 0.7 and 0.8 shows that there is a root between 0.7 less than x less than 0.8. Let's move to the next part, part B, question number 5, part B. It says that show that if a sequence of values in the interval 0.7 to 0.8 given by the iterative formula converges, then it converges to the root of the equation in part A. So basically this is the equation that we have, this is the iterative formula that we have. We need to make it the equation that was given to us in part A. So let me just rearrange it without the iteration part. 1 over 2 ln of 5 cos 3x. I'll take the 2 to the other side first. So 2 will be equal to ln of 5 cos 3x. Now I'll remove the log on from the right side. So the left hand side 2x, sorry, the left hand side it will become e raised to the power of 2x. The anti-log and the log will cancel out. It will be 5 plus cos 3x. This is the exactly same as part A. The C part says use this iterative formula to determine the root correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So the formula was x n plus 1 equals 1 over 2 ln of 5 plus cos 3xn. So first of all we have to start with the x1, and since we have the interval as 0 from 0.8 to 0.7 from 0.8, so we'll find the mid value for this, which will be 0.75. Yeah, it is going to be 0.75. I'll find the value of x. 2 from here, 1 by 2 ln of 5 plus cos 3 times 0.75. Remember that the calculator mode has to be in the radians. So let me write 0.5 ln bracket 5 plus cos. The answer is for x2, the answer for x2 is 0.7375. Each iteration should be 5 decimal places, 9 as well. Now after that, just show the do not show the working, just replace 0.75 in the calculator with the answer, and it will keep giving your answers 0.740941. So then after that, the fourth iteration, it is 0.74002 x5, the fifth iteration, I can see that the 3 decimal places, they are all almost getting the same values. So let's see for the next one. It is, if it stays the same, 0.40740 and 28. So let's do another one, sixth. So sixth, if I take another iteration, it will be 0.74209. So if you see over here, in the last two, the 3 decimal places, they are it is, the answer is 0.74021. so if you see over here, the 3 decimal places are repeating itself, so the value of x will be 0.740, the answer up to 3 decimal places. Let's move to the next question, question number 6. Question 6 says that the diagram shows the curve y is equals to this, where a is a positive constant and its maximum point is this. So maximum point means that it is a stationary point, and the stationary point means that the dy by dx will be 0. And since we are interested in finding the coordinates of x, so first of all we need to find out the dy by dx. So if you look over here, for this one we have to apply the product rule. So directly let me write down the formula for your convenience. So uv is equals to uv dash plus v u dash. Dash means the differentiation. So if I find that dy by dx for this, it will be dy by dx u as it is, which means x as it is, into the differentiation of e raised to the power of minus ax, e raised to the power of minus ax as it is, into the differentiation of the power, which is minus a, plus e raised to the power of minus ax as it is, into the differentiation of x, which is 1. So if I further simplify, it will be minus ax e raised to the power of minus ax plus e raised to the power of minus ax. Now now if you look over here, e raised to the power of minus ax is common, so let me take it out as common, and inside I will have minus ax plus 1. And since it's the stationary point, it is the maximum point, so I'll put the derivative equal to 0. One time it is e raised to the power of minus ax, it is equal to 0, which will not have any solution. And similarly a minus ax plus 1 will also be equal to 0. Now if I simplify it further, I'll be left with the value of x as 1 divided by a. This is the x coordinate for the stationary point, which is the maximum point m, but for the value of y, I'll substitute this x into the original equation. For y, I will do y equals to x e raised to the power of minus ax. Now just substitute this value of x over here. X will be, I have to replace x with 1 over a, and e raised to the power of minus a into 1 over a. This will simplify. I'll be left with the value of y as 1 over a e raised to the power of minus 1. So the coordinates of m will be 1 over a and 1 over a e raised to the power of minus 1. So this is the exact coordinates of m. Let's move to the b part. The b part says that find the exact value of this. We have to do the integration, and the limits are from 0 till 2 divided by a. So we have to apply integration by parts. So let it be u and v, the first one u and the second one v. Let me write the formula for integration by parts, which will be u v dx equals the first one as it is, the integration of the second dx minus integration of the whole of the derivative of the first multiply by the integration of the second and the derivative of integration of whole. So the first one as it is, so x as it is, integration of e raised to the power of minus ax dx minus integration of the whole, the derivative of the first, the derivative of the x is 1, multiply by integration of e raised to the power of minus ax bracket close dx. Now further I'll do the integration of the first one. So integration of this will be e raised to the power of minus ax as it is divided by the differentiation of the power, which is minus a, minus the integration of, first of all let's do the inner integration, which will give me e raised to the power of minus x minus ax divided by minus a dx. Now if I simplify it, I can take the minus a outside. It will become e raised to the power of minus ax divided by minus a plus 1 over a outside. If I do the integration of the inner side, it will become e raised to the power of minus ax divided by minus a. Now if I further simplify, it will be x e raised to the power of minus ax divided by minus a minus 1 over a square e raised to the power of minus ax. Now further I have to apply the limits. The limits were 2 divided by a upper limit and the lower limit is 0. Simplify, let's put these limits over here. The first is 2 divided by a. So if I put 2 divided by in place of x, 2 will come here. The other will go in with the denominator and it will become minus a square. Similarly, minus a bracket 2 divided by a minus 1 over a square e raised to the power of a into 2 over a. This is the complete upper limit. Similarly, for the lower limit, if I put 0 for the first one, when x will multiply with everything, it will become 0. So let's write 0. Then comes minus. Since there is a minus over there, so if I put 0 over here, it will become 1 over a square and the power will become 0, which will ultimately turn into a 1. So there is a negative over here as well. This is going to be, the upper one is going to be this is, yes. So further if I simplify, this is going to be a negative and negative. So if I simplify it further, it is going to become this cuts. So I'll be left over with 2 e raised to the power of minus 2 divided by minus a square minus 1 over a square e raised to the power of minus 2a. So ultimately, if you look over here with this one, it is going to change into a plus. So plus 1 over a square. Now if you look at the first two, let me change this negative from here to here. So these are the like terms. If you look over here, these are the like terms. So minus 2 and minus 1 will become minus 3 e raised to the power of minus 2 divided by a square plus 1 over a square. 1 over a square is common. I can take it out as common, and inside I'll be left with minus 3 e raised to the power of minus 2 plus 1. So yes, that's the final answer, because we were supposed to give the final answer in terms of in the exact form. So there is no further simplification we can do. The question number 7 says that show that cos power 4 theta minus sine power 4 theta is basically equal to cos 2 theta. So let's change. We have to convert this sine thing. We need to get rid of this sine thing into to cos. So we will do cos 4 theta minus, instead of that we can write down sine square theta whole square. And we know that there is an identity which is sine square theta plus cos square theta equals to 1. So what we can do is we can convert 1 minus cos square theta whole square. Now we can do the expansion of this bracket. So it will become cos 4 theta minus 1 plus, also we have to do the expansion. So it will be 1 minus 2 cos square theta plus cos 4 theta. Now if I further simplify, cos 4 theta minus 1 plus 2 cos square theta minus cos 4 theta. So they will simplify, and I'll be left over with 2 cos square theta minus 1. But this is what I was supposed to show. No, yeah, but we know that there is an identity that cos square 2 theta, it is equal to 2 cos square theta minus 1. This is the identity. You can even check it from the formula booklet. So I'll replace this thing with cos 2 theta. Yes, so let's move further. Part B. Yes, the part B says, hence find the exact value of this. Okay, so to find the exact value of this, let me write down integration from pi by 8 to minus pi by 8 cos 4 power 4 minus sine power 4 theta. I think this was cos 2 theta. I'll replace it with cos 2 theta minus sine 4 theta plus, sorry, it's plus 4 sine square theta and cos square theta d theta. Now this is basically we have 4 sine square theta cos square theta. We can make it a whole complete identity, like 2 sine theta cos theta whole square. This can be, why? Because we know that 2 sine theta cos theta can be written as sine 2 theta whole square. Basically this thing, this identity is equal to this identity. Now I'll replace this over here. It will become from pi by 8 to minus pi by 8, and it is cos 2 theta plus sine square 2 theta d theta. Now there are a couple of identities that I would like to write, and I know that cos 2 theta, let me write down. I know that cos 2 theta, it is 1 minus 2 sine square theta. And similarly, if I have if I have this thing cos 2 theta, I know that if it is cos 4 theta, it will become 1 minus 2 sine square theta 2 theta. Why am I doing this? I am doing it for this one. So if I rearrange it, it will become 2 sine square 2 theta. It will be equal to 1 minus cos 4 theta. And sine square 2 theta will be equal to 1 by 2 minus cos 4 theta divided by 2. Now I'll replace it over here and it will become, let me squeeze the size. Okay, so now it will become pi by 8 to minus pi by 8. So it will be cos 2 theta d theta plus pi by 8 to minus pi by 8, and instead of this sine square 2 theta, I'll replace it with this one, which is 1 by 2 minus cos 4 theta divided by 2, and it is complete d theta. Now I'll do the integration and then I'll apply the limits. The integration for cos 2 theta, it will become sine 2 theta and divided by the differentiation of the angle, which is 2. So divide that by 2, and similar I'll apply the limits as pi by 8 to minus pi by 8. Then 1 by 2 will become 1 by 2 theta minus 1 by 2 as it is. The integration of this cos 4 theta will become sine 4 theta divided by the differentiation of the angle, which is 4, and then I'll apply the limits for pi by 8 minus pi by 8. Now I'll apply the upper limit first in all of it and then I'll put the lower limit. So it will become the first one is 1 by 2 common. It is, so it is so it is going to be sine 2 times theta, which is pi by 8 plus 1 by 2 into pi by 8 minus 1 by 8 into sine 4 by pi by 8. This is the complete upper limit. Similarly, I'll put the lower limit as well. For the lower limit, I'll put 1 by 2 sine 2 times minus pi by 8 plus it will become minus, so 1 by 2 into pi by 8 minus 1 by 8 into sine 4 bracket minus pi by 8. This is the lower limit. Now if I simplify it, it will be 1 by 2 as it is. Sine of pi by 4, sine of pi by 4 will be square root of 2 by 2 plus pi by 16 minus this will simplify, it is 1 by 8 into sine pi by 2. Sine pi by 2 will be 1. So as it is, this is the upper limit. And similarly, if I talk about the lower, it will be 1 by 2 side, this is going to give me minus square root of 2 divided by 2. So I can write it as 1 by 2 square root of 2 divided by 2 minus pi by 16 minus it is going to be a negative 1, so it is going to become positive 1 by 8. Positive 1 by 8. So if I further simplify, if I expand it, it will become square root of 2 by square root of 2 by 4 plus pi by 16 minus 1 by 8 plus square root of 2 by 4 plus pi by 16 minus 1 by 8. Now if I further simplify, it will become 2 square root of 2 divided by 4 plus 2 pi over 16 minus 2 over 8. So if I simplify, the final answer will be square root of 2 divided by 2 minus pi over 8 minus 1 over 4. So this is the final answer, and I think we are supposed to give the final answer in the exact form. Let me see. Yeah, exact value of the final answer. Let's move to the next question. Question number 8. Question number 8 says that point A, B and C have position vector this and that, where O is the origin. The line L1 passes through B and C. Find a vector equation for L1. So the vector equation for L1 is basically B, C. Now first of all, we will find out the direction vector. We can find the direction vector by of BC of like OC minus OB, and it will be OC is 8, 5 and minus 3 minus OB is 5, 2 and 0. It will be 3, 3 and minus 3. It will be 3, 3 and minus 3. Okay, so let's write down the vector equation. The vector equation for L1 will be R equals the point on BC. We can use the point BC, which point we can use the point B, which will be 5, 2 and 0, and the direction vector we can use, we already just found 3, 3 and minus 3. This is the direction vector, and that is the point which is lying on the line L1. The line L2 has equation R equals to this. Find the coordinates of the point of intersection of L1. So this is a little not a difficult question, but lengthy a little. So let me divide it into steps. So step 1, I'll write down R is equal to minus 2. This is for the vector equation of line L2. 2, 1 and 4 plus mu of 3, 1 and minus 2. If I write it like this, it will be minus 2 plus 3 mu, 1 plus mu and 4 minus 2 mu. Okay, so step number 2. Step number 2 is that we already have the other one, line L1. Let me write it as R is equal to 5 plus 3t, 2 plus 3t and 0 minus 3t. Now step number 3 will be, I will put the both of them equal to each other so that I can find the value of mu or t. Basically mu so that I can find out the coordinates for the point of intersection. So it will be 5 plus 3t will be equal to minus 2 plus 3 mu. If I simplify, it will be t is equal to minus 2 minus 5 plus 3 mu divided by 3. So t will be equal to minus 7 plus 3 mu divided by 3. After that, it is 2 plus, this is the first one. The second one is 2 plus 3t is equal to 1 plus mu. Now it is, if I simplify, it is going to be, if I make t the subject, it will be 1 minus 2 plus mu divided by 3. So t will be equal to minus 1 plus mu divided by 3. So this is the other t. I'll put both the t's equal to each other. So it will be minus 7 plus 3 mu divided by 3, and it will be equal to minus 1 plus mu divided by 3. These three will cancel out. I'll be left with minus 6 is equals to minus 2 mu, and from here the value of mu will be 3. I have the value of mu now. The last step I'll perform. I know that r is equal to minus 214. R is equal to minus 214 plus mu. I know the value of mu, which is 3 now. Bracket the direction vector 1 minus 2. So if I simplify, I'll have the coordinates. It will be minus 2 plus 9, 1 plus 3, 4 minus 6. So if I simplify, it will be 7, 4 and minus 2. So the coordinates are, let me write it in the form of coordinates, 7, 4 and minus 2. Let's move to the next part. The next part says, next part is part C. For part C, it says that point D on L2 such that AB is equal to BD. Find the position vector of D. So this basically statement tells us that it says that AB magnitude is equal to BD magnitude. So let's first of all talk about the magnitude of AB. So if I talk about the magnitude of AB, it will be square root of AB. So AB, that will be, that is going to be, yes, that will be 5 minus 2 whole square plus this was x, that is y. Y is 2 and 1, so it is 2 and it will become 2 minus 1 whole square. The z is, one z is 0 and the other is 4, so it will become 0 minus 4 whole square. So if I simplify, it will become 7 square 49. This will be 1 and this will be 16 and the square root on top. So 49, 50 plus 60 is 66 square root. So D lies on, he says that D lies on L2. So we are going to use the equation. Let me write that D lies on L2. So we use equation of line to represent D. So what is the equation? the equation was d is equal to it was -2 plus 3 mu and 1 plus mu. It is 1 plus mu and other is 4 minus 2 mu. So this is the one that we have, and after that we will find out BD. BD will be D minus B. So D we already have it, and that is -2 plus 3 mu, 1 plus mu, 4 minus 2 mu, minus what is B? B is 5, 2 and 0. 5, 2 and 0. So if you simplify, -2 plus 3 plus 5 will become -2 minus 5 minus 7 plus 3 mu, -1 plus mu, and the last will be 4 minus 2 mu. This is for BD. Now I have to find the magnitude, and I know that this magnitude will basically be equal to square root of 66. So if I find the magnitude of BD, it will be let me put the square root first. It is going to be -7 plus 3 mu whole square plus -1 plus mu whole square plus 4 minus 2 mu whole square. Now if I expand it, it is going to be square root of it's going to be 49 minus 40 2 times 7 times 3 is 14. It's 42 mu plus 9 mu square plus 1 minus 2 mu plus mu square plus 16 minus 16 mu plus 4 mu square. Now and if I simplify it further, 9 plus 10, 10 plus 4, 14. So 14 mu square minus 42 minus 42 minus 2 minus 16 is minus 60 mu. So 49 plus 1 plus 16, that is going to be 66. And we know that this is basically equal to square root of 66. So we'll take square on both sides, so it will become 14 mu square minus 60 mu plus 66 minus 66 equals to 0. So 14 mu square minus 60 mu equals to 0. So we can divide both sides by 2. We'll be left with 7 mu square minus 30 mu equals to 0. Mu is common. We'll take mu common out, and that is going to give us 7 mu minus 30, which will be 0. One value of mu will be 0. The other value of mu will be 30 divided by 7. Okay, so we are not going to use the other one, as this already gives about the other point. This is already telling us about the other point, which is point A. So let's use the mu as 30 divided by 7. So we'll substitute this into the equation of L2. So equation of L2 is L2 is minus 2 plus 3. So minus 2 plus 3 times mu is going to be 90 by 7. 1 plus mu, 1 plus 30 over 7, and the last will be 4 minus 60 over 7. The final answer, if I simplify, it will be minus, it will be 76. So the position vector D, let me write, it will be 76 by 7, 1 plus 30 over 7, it is 37 over 7, 4 minus 60 over 7, which is minus 32 over 7. So this is the last position vector for this. Let's move to the next question. Question number 9. So question number 9 says that the complex number z and w are defined by this. So we need to express zw in the form of Cartesian form, x plus by or a plus bi. So let's write it there. It is going to be zw. I have to just do the expansion into 3 plus 3 square root of 3i. If I do the expansion, it will be it's minus 3. It's minus 3 plus 3 square root of 3i plus 3i minus 3 square root of 3i square. Now if I simplify, it will minus 3 plus 3 square root of 3 plus because that's I square is -1, it is going to change into positive, so that is why it is 3 square root of 3 positive. So 3 square root of 3i plus 3i. Now I can keep the real part together and the imaginary part together. 3 square root of 3 minus 3, the real part. I can take the imaginary part out. It will be 3 square root of 3 plus 3, and it will be imaginary part. Now in the next part he says that express z and w in the form of, okay, he says express z and w in the form of r is equals to I theta, where r is greater than 0 and theta is from minus pi to pi. Give the exact values of r and theta. Let me write down z first. Z is basically 1 minus I. So let me find out for z first. Let me draw. The z is going to be in this quadrant, such that it is 1 and this is minus 1. This is going to be z. If I, and this is going to be the angle theta. This is the imaginary part, this is the real axis. So let's first of all find out r first. R will be square root of 1 square plus -1 square, and it will be square root of 2. Let's find out theta. The theta will be minus 1 over 1, or you can say 1 over 1, and basically I have to find the basic angle first, and that is 1 by 1 will be pi by 4, but since it is below the x-axis, so theta will be negative pi by 4. The reason is that it is below the x-axis. So if I write down z in that form, it will be square root of 2 e raised to the power of pi minus pi by 4 I. This is the z. This is z. Now let's do that for w as well. W is so the w is minus 3 plus 3 square root of 3i. So if I make the axis for this, let me make it smaller, it's going to lie somewhere here, imaginary part and the real part. So it's going to be at minus 3 and 3 square root of 3, somewhere here. So this is going to be the basic angle, and this is the theta that we need to find out. Now let's find out the r first. So r will be equal to minus 3 whole square plus 3 square root of 3 whole square and square root. So 9 plus 3 square root of 3 whole square is 27. So a square root of 9 plus 27, so it's square root of 36. Square root of 36 will give you the value of r as 6. Now we need to find out theta. For theta, we'll find out the basic angle. Basic angle would be 3 square root of 3 divided by 3. So 3 and 3 square root of this is going to be, the basic angle will be pi by 3. So the theta will be pi minus pi by 3. So if you simplify, it is going to give you 2 pi by 3. So the theta is 2 pi by 3. So w will be equal to 6 e raised to the power of 2 pi by 3i. Let's move further. The C part says that on an argon diagram, the points represent W and ZW. ZW, we already have ZW, are A and B respectively. So A is basically, let me write down A. By A he means W, and W is a minus 3 plus 3 square root I. So minus 3 plus 3 square root of 3i, this is A. And similarly for B, it is Z times W, which is this 3 square root of 3 minus 3 square root of 3 minus 3 plus I, which is 3 square root of 3 plus 3. This is A and B. Prove that OAB is an isosceles right angle triangle where O is the origin. So let's visualize it first. Let me make the x-axis and the y-axis, which is the imaginary and the real axis. So imaginary, real, this is the origin O. If I talk about A is minus 3 and this, so minus 3 and 3 square root of 3. So A basically lies over here. If I talk about B is 3 square root of 3 minus 3. 3 square root of 3 minus 3 is something as 2 point something. It is going to lie here. 3 square root of 3 minus 3, and if I put a positive sign, this is going to be somewhat 8 point something. 8 point, this is going to be here 3 square root of 3 plus 3. So this is going to be the point B. If I join them, this is going to be a triangle. This O, A and B. Now we need to prove that OAB is an isosceles right angle triangle. Okay, so for that, what will we do? We will first of all, we know that we know that we know one thing, and that is that this angle is pi by 3. We found that over here in the previous part as well. So here, this thing, the basic angle. So we know that basically this angle is also going to be pi by 3, and this angle will be somewhat A. Okay, but before that, we know that OA is having a magnitude of 6 units. We know that from the previous part, 6 units, and it seems like that AB and OA, they are having the same sort of magnitude. So AB and OA the same. So let's write down about AB first. So AB will be B minus A. So, and B was like yes, B is ZW minus W. So ZW, we have it as 3 square root of 3 minus 3 plus 3 square root of 3 plus 3 I. This is ZW. Minus W is minus 3 plus 3 square root of 3 I. This is I. Now if I simplify, this minus 3 is going to cancel out with this plus 3, and similarly this plus 3 square root of 3 will cancel out with this minus, and I will be left over with AB as 3 square root of 3 plus 3I. Now if I find out the magnitude to prove that it is an isosceles, it is going to be 3 square root of 3 whole square plus 3 square and a square root. If you take it is going to be 27 plus 9, which is going to be 36, and square root of 36 is 6. So it proves that it is an isosceles triangle. Now we need to know this angle as well in order to prove that it is going to be a right angle triangle. So we already have the portion, we just need to find out that A. So angle OA and B. So angle OAB, it is basically going to be pi by 3 plus the angle A. So first of all, let's find out the angle A. How can we find out angle A? It is going to be the argument of basically AB. So argument of AB. So it is going to be tan inverse of AB is square root 3 divided by 3 square root of 3. So 1 by square root of 3, tan inverse of 1 by square root of 3 is, I think, pi by 6. Yes, pi by 6. So the angle is going to be, the angle A is basically pi by 6 plus pi by 3. So it is pi by 2. Yes, so it is a 90-degree triangle, right angle triangle. Its next part, the part D says, using your answer to part B, prove that tan 5 by 12 pi is equals to square root of 3 plus 1 over square root of 3 minus 1. So we'll do by trial and error. What will we have? We have basically we have that 5 pi by 12, it is basically equal to 2 pi by 3 plus minus pi by 4 from here, this angle. Now what we can do is, we know that 5 pi by 12 is basically equal to argument of w plus argument of z. So argument they are adding, so they can multiply wz. So wz we already know, wz is this thing. So as 3 square root of 3 plus I, how can I find it? Tan inverse of 3 square root of 3 plus 3 divided by the same thing but with the negative sign. So and it is equal to 5 pi by 12. So I'll take the tan to the other side. If I take the tan, it will become tan of 5 pi by 12 is equal to 3 square root of 3 plus 3 divided by 3 square root of 3 minus 3. Now 3 is common on the right side. I'll take 3 out and I will be left with a square root of 3 minus 1 divided by plus 1, 3 square root of 3 minus 1. 3 and 3 will cancel out and I will be left with tan of 5 pi by 12 is equal to square root of 3 plus 1 divided by square root of 3 minus 1. This is the one that we were supposed to prove. Yes, done. So the next part, question number 10. Yeah, question number 10 is the last question, last question, and it says, by writing y is equals to this, y secant 3 cube theta as 1 by 3, 1 by cos 3 theta, dy by dx is this. Okay, so basically he says that y is equal to cos theta whole power of minus 3. We just need to take the derivative and it will be dy by d theta, which will be minus 3 cos theta minus 4 into the derivative of the bracket, which will be minus sin theta. It is, the final answer will be minus 3 sin theta into cos theta to the power of minus 4. We know that cos theta is basically equal to 1 over secant theta. So it is sin theta into 1 over secant theta whole power minus 4. We need to make the power positive. We will flip the fraction. It will become secant 4 theta, and this is what we were supposed to show. It is, yes, it is the one that we were supposed to show. Let's move to the next part. Yeah, but there was a negative here as well, na? So this negative and this negative, they become positive, and that's, let's move to the next B part. The B part says that the variable x is equals x and theta satisfies the differential equation. it is given that x is equals to 3, and when theta is equals to pi by 3, solve the differential equation to find the value of cos theta when x is equals to 0. Give your answer correct to 3 significant figure. Okay, so what we will do is we will bring the theta to one side and x to the other. So it will be sine theta d theta over dx, it will be equal to x plus 3 over x square plus 9 cos 4 theta. It will further be sine theta over cos 4 theta into d theta. I'll take the dx to the other side. It will be x plus 3 over x square plus 9 dx. Now I'll do the integration on both sides. Before doing the integration, I will change the cos 4 theta into secant 4 theta, and that is going to be sine theta multiplied by secant 4 theta d theta. Integration of this, and on the right hand side I'll segregate both of them. It will become x divided by x square plus 9 dx plus integration of 3 divided by x square plus 9 dx. Now if I further simplify, I do integration. So if I do integration on the left hand side, I have to multiply it with 3, and I have to divide by 3 as well. And similarly on the right hand side, if I look, I have to have the differentiation of the denominator. So it is going to give me 2. I have to multiply by 2 and I have to divide by 2 as well. Similarly, what I can do is I can convert this one over here. I can convert this into tan inverse identity. Let's do it in the next step. It is going to become, if I do the integration of this one, this is going to be 1 by 3 as it is. I have this thing from the previous part as well. I can write it directly that we have the differentiation, this is the integration. It is going to become 1 over cos 3 theta, and similarly over here it will become 1 by 2 ln of x square plus 9. And similarly, if I talk about this one, I'll take the 3 out, and integration of 1 over, I'll take the 9 common, and I'll be left with x square. I'll be left with 1 plus x square over 9 dx. I have simplified this. It is going to be 1 over 3 cos 3 theta equals 1 over 2 ln x square plus 9. I'll multiply. I can change this thing, x square over 9. I can write it as x over 3 whole square, and I have to have this square parts differentiation present in the numerator. So I will multiply it with 1 by 3, and I will also multiply over here with 1 by 3. So if you see this 3 and 3, this 3 in the denominator, it is going to go in the numerator. It will multiply it with, it will become 9 divided by 9. This the 9 that is inside, it is going to come outside. So I can write down the integration of this directly, which is going to be tan inverse of x by 3. And since that's the integration, I'll add a constant in the end as well. So I have to simplify to find the value of C. So to find the value of C, no further simplification except this 9 and 9, which is going to be 1. So I know that the value of x is 3 and the value of theta is pi by 3. Now simply I have to find the value of C first by substituting these two values in here. So it will be 1 over 3 1 over 3 cos cube into pi by 3 equal 1 by 2 ln of it will be x is 3, yes, so it will be 9 plus 9 plus tan inverse of 1 plus c. Now if I simplify it, it is going to be cos pi by 3 and take the cube 1 by 2, and if I take the cube it will become 1 by 8. So it is going to be 1 divided by 3 into 1 by 8 equals 1 by 2 ln of 18 plus tan inverse of 1 is pi by 4 plus c. So this is going to be the c will be let me simplify further from here first. This will become 8 over 3, which will be equal to 1 by 2 ln 18 plus pi by 4 plus c, and the value of c will be 8 over 3 minus 1 over 2 ln 18 minus pi by 4. This is the value of c first. Now we were supposed to find the value of cos theta when x is 0. So we just need to substitute the value of x as 0. Let me write this equation first. Let me substitute the c first. This is what we have, and in place of c we will substitute the value for c, which is 8 over 3 minus 1 over 2 ln 18 minus pi by 4. Now I'll substitute the value of x being 0. So if I substitute the value of x being 0, but this is not this, let me correct this. It is theta, this is also x, x or x square, it is x square, and tan inverse of x by 3, so this is tan inverse of x by 3, and the remaining terms are correct. Yes, so I have to substitute the value of x as 0. So it will be 1 over 3 cos cube theta equals 1 over 2 ln of 9 plus tan inverse of 0 will be 0 plus 8 over 3 minus 1 over 2 ln of 18 minus pi by 4. Now if I further simplify, this is going to be, it's going to be further. If I further simplify, it is going to be I'll take this 3, it's multiplying, dividing here, I'll take it to the other side. It is going to be dividing here, it will multiply on the other side. I'll be left with 1 over cos 3 cube theta 3 over 2 ln 9 plus 8 minus 3 over 2 ln 18 minus 3 pi by 4. Now we'll change the sides. It's dividing. First of all, what we can do is we can take the cube root on both sides. So I'll be left with 1 over cos theta, which will be equal to 3 over 2 ln 9 plus 8 minus 3 over 2 ln 18 minus 3 pi by 4 whole power 1 by 3. Now I know that I have to find the value of cos theta. So let's find out the value of this first. For cos theta, when I have to flip the left side, I'll change the sign of the power from the right side as well. So cos theta will become 3 over 2 ln 9 plus 8 minus 3 over 2 ln 18 minus 3 pi by 4 whole power 1 by 3. So let me put this in the calculator. 1.5. Yes, the answer is, if I simplify, the answer is 0.60. Any decimal exact value, correct, 3 significant figure. So cos theta will be 0.601. I hope you have understood all the questions. If there is any ambiguity, any query, please leave it in the comment section. I'll try my best to answer it as early as possible. Wish you all the very best for your exam, and don't forget to share the video with your friends so that it can help them, and definitely it is going to help me in growing my channel as well. Wish you all the best. Thank you. Allah Hafiz.